Assalamualaikum warahmatullahi wabarakatuh. We are from group 9. So today we would like to present chapter 5, which is Mathematic Finance. Before I will go through, I will introduce myself. My name is Muhammad Afiq bin Ahmad Niza. My matric card number is 1202319. So let's go through to the compound interest. What is compound interest? Compound interest is the interest that is calculated on the initial amount invested, which is called as the principal, that should include all of the interest which has been accumulated in the prior periods of a loan or deposit. These are used especially in banks, capital markets, and also in stock markets to estimate growth rates. So the next part is compound interest formula. So I will guide all of you one by one. How does it work? So A is equal to P times 1 plus R divided by N raised to N times T. P is initial principal, R is interest rate, N is number of compounding periods, which could be daily, annually, semi-annually, monthly or quarterly. Last is T, time in terms of year. The next part is steps. To compute compound interest, we need to follow the below step. The step 1 is find out the initial principal amount that is required to be invested. Step 2, divide the rate of interest by a number of compounding period if the product doesn't pay interest annually. Compounding frequency could be 1 for annual, 2 for semi-annual, 4 for quarterly, and 12 for monthly. The next step is compound the interest for the number of years and as per the frequency of compounding. Last step is now deduct 1 from step 3 and then finally multiply the same by the principal amount, which shall yield the interest that will either be earned or paid depending upon whether an amount is invested or loan amount is taken. Before answering the question, we need to list the formula first to make more easier. So P is the principal. She puts in 20,000 in the account. R is the annual interest rate, which is 8%. If we divide that by 100, that's 0.08, and she received that total 8% annual interest in 12 months. So basically, that 8% is divided into 12. So her account is credited with interest every month. So divide 0.08 by 12, and we want to find out how much money will be in the account after 40 years. 0.08 divided by 12 plus 1 is 1.006, repeating. 12 times 40 is 480. After that, calculate all of it and get a value of around $485,467.79. So that's how much money will be in the account after 40 years. For the question 2, use the same equation like previous question, which is A is equals to P times 1 plus R divided by N raised to N times T. So we know future value, but he wants to have 2 million in his account. So we're looking for the P, the problem. R is the annual interest rate, 9.5% divided by 100 is 0.095, and it's compounded quarterly, that is 4 times a year. So divide by 4 and then it's raised to the NT of 4 times 45. T is the time in years. So let's find out the value of P. 0.095 divided by 4 is 0.2375, and 4 times 45 is 180. So P times 68.376152. So to solve the P, one needs to divide both sides by 68,000.376152. So P is 2 million divided by 68,000.376152 equals to 29,249 and 96 cents. So if he invests about 29,000, let's round it, then in 45 years he should have 2 million in his retirement.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ibnu Shihab bin Ibnu Muiz. My metric number 1202297. Right now I will present about the present value. Okay. The principal P that must be invested at a periodic rate of R for an interest period so that the compound amount is S is given by P equal S bracket 1 plus R, the power of value negative N, and is called the present value of S. I would like to use a present value for PV and the future value for FV. Then single payment trust fund. Okay, the question I take from ebook. Find the present value of $10,000 after 15 years if the interest 1.4% compounded quarterly. Okay, the answer is FV is 10,000 and R 1.4% equal divide by 4 and N 15 multiplied by 4. Why you choose 4? Why use 4? Because a compounded quarterly. And the PV is 10,000 bracket 1 plus 0.0035, the power of value negative 60, and we get 8,108.81 dollar. Second, two future payment by a single payment now. Okay, the question, to settle an obligation, you are required to make a single payment that has 1,500 due in 5 years and the remaining 750 due in 2 years, with both having the same interest rate of 8% compounded semi-annually. How much do you have to pay now? The answer is FV 1,500 and R 8% divided by 2 and equal 5 multiplied 2. Why we use 2? Because semi-annually. And the second, 750 R equal to 8% divided by 2 and N 2 multiplied by 2. Okay, the PV 1,500 bracket 1 plus 0.04, the power of value negative 10 and plus 750 bracket 1 plus 0.04, the power of value negative 4. We get the answer 1654.45. Then the next question. A debt of 500 due in 4 years and 1,000 due in 6 years is to be repaid by a single payment 3 years from now. If the interest rate is 4.4% compounded quarterly, how much is the payment? Okay, the answer is FV 500 and R 4.4% divided by 4 and N 1 multiplied by 4. The second FV is 1,000, R is 4.4% divided by 4 and N 3 multiplied by 4. Okay, the PV is 500 bracket 1 plus 0.011, the power of value negative 4 and plus 1,000 bracket 1 plus 0.011, the power of value negative 12. Okay, we get the answer 1,355.56. Why the years is 1 and 3? I will expand into a graph. Okay. We draw the graph. Okay. 1, 2, 3, 4, 5, 6. Okay. Cos. Okay. Is 0, 1, 2, 3, 4, 5, 6. Okay. The question is the 500 due in 4 years. 500 due in 4 years. 500. Right. And 1,000 due in 6 years. 1,000. 1,000. And this the question is to be repaid by single payment 3 years from now. This means the payment must pay it at 3 years from now. Is 3. Okay. And we calculate the years. Okay, 4 to 3 years is 1 year, right? 1 years. And 6 for to 3 years is 3 years, right? This is why the years is 1 and 3. That's it. Okay, thank you. Okay, then a net value, present net present value. Okay, net present value. The question is the lump sum of the 250,000 was invested in a project that has following cash flows, and year 5, 6, 7, and 8 the cash flow the shows is like table. Okay. Assume an interest rate of 1.2% compounded monthly. Find the present A. Question for A. Find the net present value of the cash flow. And the B is the investment profitable. Okay. Then the answer A NPV equal to 60,000 bracket 1.001 the power of value negative 60 plus 65,000 the bracket 1.001 the power of value negative 72 plus 86,000 the bracket 1.001 the power of value negative 84 plus 97,000 bracket 1 to 1.001 the power of value negative 96 and minus 250,000 that we get answer 34,193.89 the answer of B NPV bigger than 10 that's the business venture is profitable. That's from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zamri, metric number 1202316, and today I will be presenting about future value. Okay, let's start with the definition of future value. Future value is the value of a current asset at a future date based on an assumed rate of growth. The future value is important to investors and financial planners as they use it to estimate how much an investment made today will be worth in the future. Knowing the future value enables investors to make investment decisions based on their anticipated needs. There are two ways of calculating the future value of an asset, which is first one is using simple interest, and the second one is using compound interest. As I said before, there are two ways of calculating future value. The first one is future value using simple annual interest. It is the additional of the principal amount that we have in the beginning and the interest earned on the principal amount after the completion of the period. It is assumed that the interest rate is earned only on the initial investment. The formula is for FV equals to I times 1 plus R times T, where I is investment amount or present value, R is interest rate, and T is number of years. The second method is future value using compounded annual interest. It is similar to the simple interest, but the difference occurs from the second period of time. The interest is also calculated on the interest thus earned on the previous period of time. The rate is applied to each period's cumulative account balance. The formula is FV equals to I times 1 plus R the power of T, where I is investment amount or present value, R is interest rate, and T is number of years. Okay, for now I will show you an example of future value using simple annual interest. The question is, if Sam lends $1,500 to his friend at an interest rate of 4.3%, find the future value after 6 years by using future value simple interest formula. Okay, so the answer is initial amount equals to $1,500. The rate is 4.3% and the year is 6 years. Okay, the question asks us to find the future value after 6 years. So we use the future value using simple annual interest formula, which is FV equals to I times 1 plus R times T. And we add up the numbers. FV equals to $1,500 times 1 plus 0.043 times 6. And then we got the answer, $1,887. So now this is an example of future value using compounded annual interest. The question is, when Jamal graduated from college recently, his parents gave him $1,650 and told him to use it wisely. Jamal decided to use the money to start at a retirement account. After doing some research about different options, he put the entire amount into a tax-deferred IRA that pays 15% interest, compounded annually. Calculate how much money Jamal will have in his IRA at the end of 10 years, assuming that the interest rate remains the same and that he does not deposit any additional money. The answer and explanation is initial amount, which is PV, is $1,650. The rate is 15% and the year is 10 years. The question asks us to calculate the future value of the deposit. So we use FV equals to I times 1 plus R the power of T. Then we put the numbers. FV equals to $1,650 times 1 plus 0.15 the power of T, a power of 10. And then we get the answer, $6,675.17. That's all from me. Thank you.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Naufal bin Zulkifli and my matrix number is 1202315. In this video, I will talk about annuities. Firstly is the introduction. Annuity can define as finite series of equal payments that occur at regular intervals. There are two types of annuity. First, if the first payment occurs at the end of the period, it is called an ordinary annuity. And second, but if the first payment occurs at the beginning of the period, it is called an annuity due. This is the formulas for present value. R is the term of investments, N is the period payment, and R is the interest rate per period. We go through the question number 1. Suppose you win the publisher clearinghouse $10 million sweepstakes. The money is paid in equal annual end of year installments of $333,333.33 over 30 years. If the appropriate discount rate is 5%, how much is the sweepstakes actually worth today? So firstly, we have to identify what formula we have to use, present value formula or future value formula. The keyword is actually worth today, which means present value. Then, identify. The question is about ordinary annuity or annuity due. The sentence annual end of year installments defined as ordinary annuity. So the formula we use is present values ordinary annuity formula. Then we must find the information given. So what we get is we have capital R, which is the payments, $333,333.33 $333.33 cents. We also have small r or rate that have to convert to decimal number, which is 0.05. And we also have end, as the period year is 30 years. After we got all the information, we just put into the formula and press the calculator to get the answer. So the answer is $5,124,150.29. Then we go to the next questions. The next question is, the premiums on an insurance policy are $50 per quarter, payable at the beginning of each quarter. So at the beginning of each quarter means annuity due. If the policyholder wish to pay 1 year's premiums in advance, how much should be paid, provided that the interest rate is 4% compounded quarterly? So the questions is not states what the value for the future. So we defined the question as the present value questions. So the formula we use is this, and then we have to find the informations. So we have capital R, which is $50. We have small r, which is 0.01. How can we get 0.01? Because the question said compounded quarterly. So quarterly, which means 4. So 0.04 must divided by 4. And then we also have end, which is 3. Why 3? Because one of the quarter payment have been paid at the beginning. So we can use the timeline to understand the period payment. And then after we got all the information, we just put in the formula, and then we press the calculator. We got the answer, 197.05 cents. Then we move to ordinary future value. So this is the formulas for future value for ordinary annuity and annuity due. So the information for the terms is basically same with the terms in present value. So examples for future value of annuity. The question is, suppose you begin saving for your retirement by depositing $2,000 per year in an individual retirement account, which is IRA. If the interest rate is 7.5%, how much will you have in 40 years? So same steps. Identify the questions. Key sentences is how much you will you have in 40 years. It is future value, and the question is not mentioned about the types of annuity, so we can define it as ordinary annuity. So the formula is future value and ordinary annuity formula. Then identify the info. Capital R is $2,000. Small r is 7.5% and convert to decimal point, which is 0.075%, and the end is 40 years. After that, put in the formula, press the calculator, and the answer is $454,513.04. We move to the next question. The question is, you are saving for a new house and you put $10,000 per year in an account paying 8%. The first payment is made today. How much will you have at the end of 3 years? Sentence the first payment is made today defined as annuity due. And the question also want the value we have at the end of 3 years, which means future value. Then we must find the information. So the capital R is $10,000. The small r is 0.08 and the n is 3. After that, put in the formula and the answer is $35,061.12. So we go through to sinking fund. So this is the formula for sinking fund. S defined to the total cost of property minus to salvage value. N and R is same with annuity for present and future value. The example is a sinking fund is a fund into which periodic payments are made in order to satisfy a future obligation. Suppose a machine costing $7,000 is to be replaced at the end of 8 years, at which time it will have a salvage value of $700. In order to provide money at that time for a new machine costing the same amount, a sinking fund is set up. The amount in the fund at the end of 8 years is to be the difference between the replacement cost and the salvage value. If equal payments are placed in the fund at the end of each quarter and the fund earns 8% compounded quarterly, what should each payment be? So we must find the information. So this is the formula. The total cost of property is $7,000 and minus the salvage value, which is $700. So we get $6,300. Small r is 0.08 divided by 4, which is 0.02. It must divided by 4 because the question said compounded quarterly. The n is 32 years because we have to pay 4 times every 1 year based on the sentence. If equal payments are placed in the fund at the end of each quarter, so we must multiply 8 years with 4. After that, put the information into the formula and the answer is $142.45. So that's all for the annuities. So I hope we can learn something new and apply it to our daily life. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Mirza bin Muhammad Nur, number matric 1202323. So now I would like to show you about the amortization. So what about the amortization? Amortization is an accounting technique used to periodically lower the book value of a loan or intangible asset over a set period of time. It is also refers to paying of debt amount on periodically over time till loan principal reduced to zero. In relation to loan, amortization focuses on spreading out loan payment over time. Amount paid monthly is known as EMI, which is equated monthly installment. EMI has both principal and interest component in it, which is calculated by amortization formula. Now, on this slide shown a formula of amortization and a formula for interest. Before that, we can look at the purple box that have a meaning of the symbol in the amortization formula. We can start with the symbol of P. P is the principal. R is the rate of interest. And symbol T is the time in terms of year. N is the monthly payment in a year. And symbol I is the interest. And lastly, symbol P but have a hook at its head, which is the monthly payment or EMI amount. So now, look at the formula amortization again. That shown EMI equal to RP divided by N times bracket 1 minus bracket 1 plus R divide N close bracket negative square root NT. So this is the formula for amortization. Now, for formula interest is interest equal to N times EMI amount times T minus P. Okay, that is all the formula for interest. Now, I want to show you the example of how to calculate amortization. The situation is given: a salaried person took home loan from a bank of 150,000 ringgit at the rate of interest of 10% for a period of 25 years. Now, we have to calculate the EMI amount and interest component paid to the bank. So, first thing first, we come out all of the information we got from that situation are given. We got the principal is 150,000 ringgit. Rate of interest is 10%, and we can change from percent to decimal, and we got the 0.1. And time in terms of year is 25 years. And lastly, we got the monthly payment in a year is 12 months. Now, with using the amortization formula, we just put the info what we got from that situation and just calculate that. Alright, now let's calculate it, which is EMI amount equal to 0.1 times 150,000 divide 12 times bracket 1 minus bracket 1 plus 0.1 divide by 12 close bracket negative square 12 times 25 close bracket. And we just using the calculator for calculate it, and now we got the answer which is 1363 .0511, and that's the answer for EMI amounts. And we continue with the calculate interest paid. Okay, we know the formula for interest is N times EMI amount times T minus P. So we just put all the information are given on the formula, which is interest equal to 12 times 1363.0511 times 25 minus 150,000, and we got the answer with using calculator again. We got the answer is 258,915 and 30 cent ringgit for the interest paid. So this answer told to us the interest for salary to payable. So that's all for me. Assalamualaikum warahmatullahi wabarakatuh. Thank you.